Hydrocarbons are substances composed of hydrogen and carbon atoms. These hydrogen and carbon atoms could be bonded as well by single, double, or triple bonds. The type of bonding determines its classification. We have three main classifications by the type of bonding. We have alkanes, which are hydrocarbons bonded by a single bond, alkenes, which are hydrocarbons bonded by double bonds, and alkynes, which are hydrocarbons bonded by triple bonds. As well, we have another way of representing these hydrocarbons or arrangement, which are the aromatics or cyclic hydrocarbons. These are hydrocarbons that form rings.
Of alkanes, we have here a condensed structure called 4-ethyl-2-methylhexane. How do we name it first? Well, following the IUPAC rules, first we have to find the parent chain. Very quickly, this can be a parent chain with 6 carbons. This also can be a parent chain, and this also can be a parent chain. So choose anything. I will choose this one. So it's 1, 2, 3, 4, 5, 6. So we have 6 carbons. So the name of 6 carbons in alkanes is called hexane, and it has a suffix of ane. Good. Now this word is the location of where are the side chains. So we have in here side chains. This is called methyl and this is ethyl. So 1, 2. In group 2 we have methyl, and group 4 we have ethyl. So when writing it, we need to follow an alphabetical order. So first you put ethyl because it's first. So in position 4 we have hyphen ethyl, another hyphen, position 2 methyl hexane. Ethyl methyl is alkyl group, so it's called like that. And there you go. Now here we have an example of alkenes. So this condensed structure is called 1,4-hexadiene. So let's see why it's called like this. So first, as always, find the parent chain. Well, this is just one, so this will be the parent chain. Well, this is simple. When we have double bonds or triple bonds, we have to have the priority to follow them the way in which the double or triple bonds are starting. So it means that from here we have to start counting. So we have 1, 2, 3, 4, 5, 6. So these are the positions or groups, as you wish. So in naming alkenes, we have to name the location first of where is the position of the double bond. So the position 1 we have double bond, and in the position 4 we have a double bond. So writing it 1,4 means that in position 1 and 4 we have hyphen hexa because it's 6 carbon atoms tie in. Why tie in? Because it has 2 double bonds. So it's di, the prefix di, and the suffix in for alkenes, and that's it. But when there are side chains, you will first write them here in alphabetical order, and then this, and that's it.
So to name alkynes, we normally use the IUPAC nomenclature. So the first thing that we need to do is to find the longest carbon chain that includes both carbons of the triple bond. Now the second thing is to number the longest chain starting at the end closest to the triple bond. For example, here, the end nearest to the triple bond is this one, so we start numbering from here to here. And after doing this, we have to find the substituents and to label them. And after doing this, we just have to write the name of the molecule.
Now I'm going to talk about aromatic hydrocarbons. Aromatic hydrocarbons are the ones that contain a benzene ring. A benzene ring is a 6-membered ring with 3 double bonds. And a characteristic of an aromatic hydrocarbon is that it can have multiple names that is associated with its structure.
When naming organic compounds, you first count the number of carbons in the longest carbon chain. This gives you the root or the father chain. For example, if the longest chain is 1 carbon atom, you use meth. If it has 2, you use eth. If 3, you use prop, etc., etc. So first, we're going to look at the alkynes. The alkynes are saturated hydrocarbons, which means they have carbon-to-carbon single bonds. And the first alkane with 1 carbon is methane. Next, we have 2 carbons, which is ethane. The next example has 4 carbon atoms, and it is called butane. And finally, this has 6 carbon atoms, called hexane. And the general formula for the alkanes is CnH2n plus 2. Next, we'll look at the alkenes. The alkenes are saturated hydrocarbons, which means they have carbon-to-carbon double bonds. The smallest alkene has 2 carbon atoms, which is ethene. Next, we have propene with 3 carbon atoms. And the final example has 5 carbon atoms. And here, because there is more than one position in which double bond could end up, we use a number. So this is carbon number 1, this is carbon number 2, and the double bond starts here until carbon number 3. We gotta give it the lowest number, so we're gonna use 2. For this, it'll be called pent2-ene. And the general formula for the alkenes is CnH2n. Finally, we have the alkynes. The alkynes are saturated hydrocarbons, and they have carbon-to-carbon triple bonds. So, starting with the smallest alkyne, we have ethine with 2 carbon atoms. Next, we have 3 carbon atoms, which is propane. And when we get to 4 carbon atoms, there is more than one position for the triple bond to be. So, just for the like of alkenes, we assign a number. So, we count carbons, this is carbon 1, carbon 2, and we get to the triple bond from 2 to 3. Again, we use the lowest number, so it ends up being called but2-ine. Okay, this is a general formula. The formula for alkynes is CnH2n minus 2.
Organic chemistry is so important because it has many applications that can benefit in our surroundings. For example, it can be included in medicine is a prime store of organic compounds because it can make drugs to cure diseases and many other studies that can use this kind of chemistry. Also in food materials are solely made of carbon compounds like carbohydrates, proteins, and fats. Even vitamins are organic in nature. Briefly, organic chemistry finds its application largely in the field of medicine, pesticles, petroleum sector, textile, and many more things that can be used for analysis, for synthesis, and better molecules.